Good morning all. So let us continue the preliminaries on our series. Now if the series summation n equal to 0 to infinity n x raised to n converges for mod x less than r, where r is greater than 0, and if it has a sum f of x, then we have f of x equal to summation n equal to 0 to infinity an x raised to n, so that is a0 plus a1x plus a2x square plus etc. Now if your series converges, then you can see that f of x is equal to this sum. So therefore f of x is continuous and differentiable for all orders in the interval mod x less than r. So f of x is continuous and has derivatives of all orders for mod x less than r. So therefore we can differentiate the series term wise, so we can obtain the derivatives of f of any order. So therefore the series can be differentiated term wise, and we'll get f dash of x to be, so that will be summation n equal to 1 to infinity n an x raised to n minus 1, so that is a1 plus 2a2x plus 3a3x square. So, and similarly you want to find f double dash of x, so that is summation n equal to 2 to infinity n into n minus 1 an x raised to n minus 2, so that is 2a2 plus 6a3 x plus etc. So that is the successive derivative of your series, and you can find the derivatives of any order. And here, when you are taking the derivatives, you can observe the following fact. So we have f of x equal to a0 plus a1x plus a2x square. So when x is 0, you will get a0 equal to f at 0, and in the second equation, when x is 0, you will get a1 equal to f dash of 0. Then you have a2 equal to f double dash of 0 by 2 factorial vary. അതുപോലെ a3 will be f third derivative of f by 3 factorial, so on. So therefore we can obtain, so an will be 1 by fn of 0 by n factorial. And similarly the series can be integrated term wise also. So like we did the differentiation, you can take the integrals also term wise. And again if you have a series which converges to the sum g of x, so if there is a series g of x equal to summation n equal to 0 to infinity bn x raised to n, where you have mod x less than r. So if you have the same interval of convergence, then if you take f plus or minus g of x, so that will be equal to summation n equal to 0 to infinity an plus or minus bn x raised to n. So if you have the same interval of convergence, so when you take the sum of the series, it will again converge to f plus g, and the difference of the series will converge to f minus g. And we can also define the product of the series. If you want the f of x into g of x, so that can be put in the form of a series summation n equal to 0 to infinity cn x raised to n. So here cn will be a0 bn plus a1 bn minus 1 plus etc. an b naught. Now let us look into the next result. So let f of x be a continuous function that has derivatives of all orders for mod x less than r, where r is greater than 0. Now let us look whether f of x can be always put in the form summation n equal to 0 to infinity f(n) at 0 by n factorial into x power n. So this expansion need not be valid everywhere. So your function in general cannot be represented in this form. So let us see when can our function be put in this form. So for this we use the Taylor's formula. So this series is actually the Taylor series. So let us look when is the Taylor series valid. So we have f of x equal to summation k equal to 0 to n fk at 0 by k factorial into x raised to k plus rn of x. So here rn of x is the remainder term, and the rn of x is equal to fn plus 1 n plus 1 derivative at some point x bar into x bar n plus 1 by n plus 1 factorial. So x bar is a point between 0 and x. So x bar is some point between 0 and x. Now f of x converges to the series summation k equal to 0 to infinity fk at 0 by k factorial into x raised to k provided. So rn of x must go to 0 as n tends to infinity. So if the remainder term converges to 0 as n tends to infinity, then in that case only your series series will converge to, it is in the opposite way, the series will converge to f of x. So that is the condition for your function to have an expansion of this form. So the remainder term must converge to 0 as n approaches to infinity. So let us now move on to the next result. The next result is, so if function f of x has property that it has power series expansion of the form so if you have f of x equal to summation n equal to 0 to infinity n x minus x naught whole raised to n is valid in some neighborhood of x naught, then f of x is said to be analytic in that case. So f of x is said to be analytic at x naught. So if a function is analytic at a point x naught, then it will have a power series expansion about that point. So here an in this case will be given by fn of 0 by n factorial. So that will be the value of an, and this series is also called as the Taylor series. So I think you have learned in complex analysis already. For function analytic anengil, so it will have a Taylor series expansion about that point. Now let us see a problem. So the question is, if p is not 0 or a positive integer, show that the series summation n equal to 1 to infinity p into p minus 1, p minus 2, etc. p minus n plus 1 into x power n by n factorial converges for mod x less than 1 and diverges for mod x greater than 1. So let us use the ratio test. So by ratio test, so limit n tends to infinity, mod an plus 1 by an will be, so limit n tends to infinity, modulus of an plus 1 is p into p minus 1, p minus 2, etc. p minus n plus 1 അടുത്ത term p minus n വരും into x raised to n plus 1 by n plus 1 factorial into, so you have p into p minus 1, etc. p minus n plus 1 into x power n. So numerator you will have an n factorial also. So that will be equal to limit n tends to infinity, mod x 1 by n plus 1, numerator you will have p minus n. So that will be equal to, so the limit of this will be equal to, our modulus here. So that will be limit n tends to infinity, limit of this term will be equal to mod minus 1. So you will have mod x into modulus of minus 1, so that is mod x. So therefore by ratio test, the series converges if, so the limit L, so this will be the value of L, series converges if L less than 1, so that implies mod x is less than 1, and any mod x less than 1 is series convergent ആയിരിക്കും. Now by the ratio test again, when L greater than 1, the series diverges. So when L greater than 1, series diverges. So therefore we have series converges when mod x less than 1, and it will diverge when mod x is greater than 1. So that is the required result.